Rational functions. We will look at finding domain and finding asymptotes. A rational function is a function that's written in the form where you have a polynomial function in the numerator and you have a polynomial function in the denominator. Of course, since you have a function in the denominator, you have to be sure that denominator is not equal to 0. So anytime you have a function like this, we call it a rational function. Okay. When you're dealing with the domain of a rational function, because we have a denominator, we have to restrict the domain to values that will not make the denominator 0. So the domain is going to include everything except the values that make the denominator 0. So to find the domain, we have to find where the denominator equals 0. So in this case, x minus 6, I take x minus 6, set it equal to 0. I solve that by adding 6 to both sides. So x equal to 6 is not in the domain. So we can say that two different ways. We can say the domain is everything except for the value 6, x is not equal to 6. Or we can write it in interval notation. In interval notation, let me do it this way, wrong symbol there. Interval notation, negative infinity up to 6, don't include the 6, and union it with 6 to positive infinity. Rational functions have properties that we refer to as asymptotes. Asymptotes are lines. In this case, they're going to be vertical lines or horizontal lines that kind of serve as a boundary for the graphs. They are not actually part of the graph, but they tell you a lot about what your graph is going to be, how your graph is going to be behaving. So when we have a rational function that's in lowest terms, that means we cannot remove any factors. There are no common factors between the numerator and the denominator. Then the graph will have a vertical asymptote at any value k, which makes the denominator 0. So in other words, wherever you found your values that you restrict from your domain, you're going to say that those are your vertical asymptotes. So for this problem that we just looked at, we said that our domain was everything except x equals 6. That means the vertical asymptote is the line x equals 6. Now I want to look at that on the calculator. I want you to look at the graph so you can see the asymptote. Here I have the graph, 4x plus 7 divided by x minus 6. Now notice that I had to put the numerator in parentheses and I had to put the denominator in the parentheses. Now if I look at a standard window, zoom 6, I see some funny stuff going on there at the value of x equals 6. I'm going to extend my window out just a little bit further. Let me go out to a x value of 20. What you see is this graph has a big jump here. We have a graph that's kind of going down here. It's actually going down to infinity. And then we have another part of the graph that's up here. This line, looks like a vertical line here, is actually the vertical asymptote. The vertical asymptote is not part of your graph, but sometimes the calculator will show the vertical asymptote. This graph, oops, that's not very straight here. actually looks something like this. And the asymptote should be shown with a dotted line. Sometimes it just shows up as a solid line in your calculator. If we go to the table, I want you to see that when you have the x value of 6, you do not have a y value. So you see the error in your table when x is 6. Okay, now let's look at the second function here. G of x equals 4 over 2x plus 5. My vertical asymptotes here are going to be where the denominator equals 0. So I do 2x plus 5 equals 0, and then I solve that. I subtract a 5 from both sides, and then I divide by 2. So my vertical asymptote here is the line x equals -5/2.